Greetings, everybody, and welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho, and my rage levels are still manageable, like they were yesterday, hence the normally colored flames. Let's start talking about space. Are you a spaced out viewer? Please leave us a comment if you're a spaced out viewer. Yesterday, I was wrong about the coronal mass ejections and their Earth-facing trajectory. Survey said. So I was wrong about being right. I was right about being... How does that work? Anyway, we see a coronal mass ejection on the opposite side of the sun, coming out this way. The Earth would be over in this direction. And yesterday we covered a coronal mass ejection that is Earth-facing. It's fairly diffuse. Some part of it will probably strike the magnetosphere in about 48 hours, would be my guess. So let's give you a look at that and get rid of that. By the way, we are streaming live, folks. Before we talk about that, let's look at the LASCO C2. So here you can see ejecta coming out of the left side first and then coming out of the right side. So here's the east over here, where space weather rises, and here's the west over here, where space weather sets. And this satellite is in between the Earth and the Sun, called the SOHO. And you can see that is all from one coronal mass ejection, folks. So the fact that you see this on both sides here indicates that there's some kind of a Earth-facing component, most assuredly associated with that one. Wasn't expecting to report that, but there you have it. Next, we'll look at the full disk here in 193 angstroms. And we see some X-ray flaring having happened, as well as another active region up here. So more cycle 25 behavior, a decent amount of plasma on the surface of the sun right now, and a bunch of filamentary behavior. We're going to try to keep the video a little short today. And again, thanks for tuning into the smAsho stream, if you did. We are streaming live to Twitch, and there you have that. Let's go to HelioViewer, look at the fields. Can't see the rising fields very well yet. I don't think we have a sunspot. We'll look at it by the end of the video. As that active region sets, we're going to have to ignore that for today. Here's the 304 angstroms. And there's the fade to 171, which, by the way, is my favorite if you are a new viewer. 171 angstroms is one of the UV spectra of ionized iron. And let's take a different view here. Let's look at the 304 angstroms 48-hour SDO video. As we have a large plasma filament standing up there in the northwest. So let's see if we can figure out where that X-ray flare came from. And by looking at this, I am not sure. My best guess is that that X-ray flare came out of this plage, which is not a sunspot, by the way. This plage right here. Let's look at more data. There's the KP index. It's at 1. The 10.7 centimeter radial flux has actually dropped down to 68. And by the way, that can happen when plasma is in between the sun and the Earth, as it causes radio signal refraction. When radio waves pass through magnetic field-oriented plasma, it has a tendency to affect the photons. The photons don't affect the protons much, but the protons affect the protons. The protons affect the photons a lot. We'll be streaming for the solstice, folks, so if you want a timeanddate.com countdown, just go to their timers. Better yet, I don't remember where it is. Anyway, timeanddate.com, it's a great site. We'll be streaming live at the moment of the solstice, where I'm located, which is in eastern Pennsylvania, but not Allentown per se, is 5:43 p.m. and 40 seconds. How do you like that? That would be where the sun reaches its northernmost point in the northern hemisphere and the southernmost point in the southern hemisphere in terms of its spot on the ecliptic. Next, looking at where stuff is in the solar system. Here's a view from theplanetstoday.com. There's where things will be in a week. as Mercury swings through. We should be able to see it on the LASCO C2 and C3. It might even already be on the C3, but I don't think so. Give that a couple days. It'll be fairly spectacular. Here's the star chart of yesterday, and here's where they are today at 4:44. And if you're up before dawn, you should see Jupiter, Saturn, and Mars up there. And there are the X-ray flares. We actually did see a B-class flare. I'm pretty sure it came out of that plage. We'll look at the 94 angstroms view before we close out the video. Proton flux doesn't really see anything, and we're not expecting to see any sort of a big increase in this because of that coronal mass ejection, because it's fairly diffuse. It's not super high speed. The magnetosphere will deflect probably most, if not all of that. So here's the real-time solar wind data, and we see a phi angle down at 73 degrees. Solar wind density 4 protons per cubic centimeter or so. Solar wind density 4 protons per cubic centimeter. Solar wind speed having come off of its lows below 300 kilometers a second, a true solar minimum solar wind speed, now up to about 312 kilometers a second. And we'll talk cosmology for a quick moment once again, as we've got cosmology playlists on the YouTube channel. We've got a cosmology forum at smashomash.com/forum. Perhaps check that out if you haven't checked it out before. So today's cosmology segment shall feature some information about signal-to-noise ratio recently put up by the channel Sky Scholar, hosted by Dr. Pierre-Marie Robitaille, and also the current information on cosmic ray flux. So here's the Opacity neutron monitor. 30 days of data show us a relatively flat trend there. Barentsburg, big uptick at Barentsburg in the past 2 days. Check it out. There's a big uptick at Barentsburg, making the entire trend for 30 days significantly upward. So that's an interesting one, folks. Next, looking at Athens, Greece, much farther south, much closer to the equator, if you will, and that is flat also on the past 30. Mexico City's next. Fairly flat in the past 30 days there at Mexico City. Moscow is still looking kind of funky. And there you can see their X-ray flares. Hey, this site's okay, folks. What do you think? There's the ACE data. Nice. Anyway, we'll look at that at another time. We usually only use this segment for cosmic rays. Here's Oulu, Finland, as well as DOMC Antarctica. There's Oulu. And quite flat in the past 30 there. There's DOMC Antarctica. Slight downtrend at DOMC. Don't take my word for it. Monitor the cosmic rays yourself if you like. And here's a tidbit from yesterday's Sky Scholar video. And this is how the microwave background map is generated. What you're looking for is the microwaves in region 0, which requires you to subtract region 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 from region 0. And before I play you a little tidbit, let me read my comment. So those of you who see my community post would have seen this same comment. With only billions of variable stars and billions of galaxies emitting microwaves, what could possibly go wrong when attempting to find a completely theoretical cartoonish concept like a residual cosmic microwave background? It's nuttier than squirrel turds. Every single galaxy and star in that image is variable to some degree, and who in their right mind would think they can get a clean signal? Radio Galaxy Cygnus A, which we're going to make a t-shirt of, 3C405 is an alternate name for that radio galaxy, is a stronger radio source than anything in the entire sky besides the sun. Its estimated distance is 530 million light years. Now think of the implications of all of those other radio sources within, much less outside, the Milky Way galaxy. Trying to isolate a signal like this is similar to taking a photo of your own hand with a signal-to-noise ratio of 1.1, placing your hand on the paper, drawing a turkey, and then eating the paper because it leaves a taste, a bad one, in the mouth. Take it away, Robitaille.
To 2.0446, a change.
This is the correction in the measurements that they took on year 1 versus the 3-year average. And you can see the correction bands the correction on these bands is, the ratios of these is completely insane.
Change of 6%. Finally, we come to W band. The value changes from minus 0.250 in year 1
Look at the ratio of the Q band. The Q band is the best. Check this one out.
The next column is Q band, and the change is stunning. From negative 0.096 in year 1 to positive 0.0297 in year 3.
So that's a signal-to-noise ratio of...
The sign has completely changed, and the absolute value of the coefficients differ by more than a factor of 3.
It's a factor of 3 in terms of error correction on the 3-year average of the Q band of region 0. So there you go. There's your anisotropy map. It's not anisotropic. And so watch the Sky Scholar video if you haven't. And if you haven't, headed to smAshomash.com/forum. Check it out. There's a cosmology forum there. You may find it interesting. Let's get back to data. Here's the magnetosphere data showing the density, courtesy University of Michigan Geospace Model V1.5. And allow me to vanish and then check the chat. Anyway, there's 4 hours of data on the density, and you can see that quite low solar wind density, as well as a bit of an oddness over here in the meridional plane view. Nothing too crazy though, everything looks fairly normal, just a bit of a weak magnetosphere, and no surprise having the solar wind drop to below 300 kilometers a second. So anyway, there you go. And if you're wondering what these empty spaces are, those are the plasma spheres, which are held in place by the Van Allen belts, which is where the plasma orients. The plasma orients to the magnetic fields. Anyway, let's let that play through again as it refreshed right at the end to show you a clean 4 hours of pressure data on what was going on in the magnetosphere according to the Space Weather Modeling Framework, which is the basis for University of Michigan Geospace Model V1.5. Read all about it by clicking on the Details tab, if you like. Next, looking at ground magnetic perturbations. And there aren't a lot of perturbations going on, as there's not a lot of induction, and there's not a lot of magnetic monkey business going on right now. And there's 4 hours of data showing you that during this polar excursion, which I will not talk about in this video. Perhaps we'll do a special about polar excursions. Maybe on the next Diamond Anvil, Too Hard to Smash. GOES magnetometer is quite spiky and quite all over the place. If you're a new viewer, the N's and M's mean midnight and noontime for the GOES 16 satellite. As when there's an Earth in between the GOES satellite and the Sun, it gets a lower magnetometer reading than it does when it's directly in between the Earth and the satellite at Lagrange point 1, near Lagrange point 1. And next, looking at the top view ecliptic plane field plot. By the way, talking about Lagrange points, the SpaceX launch did not happen yesterday. There are 4 launch windows over the weekend on both Saturday and Sunday, so we're hoping to see that go off without a hitch, and wishing those 2 American astronauts flying American gear out of America a good trip to the International Space Station. Top view ecliptic plane field plot is showing us a entirely South Pole oriented current sheet in our region, unless you're viewing from someplace besides Earth. If so, please leave a comment if you're viewing from a different galaxy, multiverse, universe, plane of existence, etc. Or perhaps from a spaceship. Please leave a comment if you're James T. Kirk, the Pleco, who's boldly gone where no Pleco has gone before. There's a line of sight field plot, and we're looking at an hour and 19-minute old data there. Nothing to write home about there. No big changes in the B field shown in blue. Wait till we get some sunspots, you'll see big changes. Electron flux is still absolutely cratered. Look at that insane relativistic electron flux there. It's not at that low of a level, but it's at an incredibly stable level and significantly low. That's the greater than 2 mega electron volts electron flux. Here's the greater than or equal to 2 mega electron volts electron flux. And where has the GOES 15 gone? I don't know where it goes, Let's hope it hasn't goes into the ocean. Let's hope the goes ain't goes, and let's hope the goes didn't go into the ocean. Or have some other kind of mishap, because those things are in some danger up there. And the total electron content, very low. This is the lowest we've seen in quite a while. And there you see an estimation of the entire column from the thermosphere all the way down to the plasmasphere. Or I should say up to the down to the plasmasphere. The thermosphere being the most measurably diffuse portion of the Earth's atmosphere, the part that is most directly affected by the sun, the thermosphere. Next, looking at the ionosphere map, this is just one layer. This is where the ions happen, folks. And this is looking a little bit anomalous here, but much more normal than it has been. And we saw some very weird ionospheres on the past few days. Watch previous space weather videos. They're all in a playlist. Here's the latest image coming in at 8:45, looking fairly normal there on the ionosphere. Next, looking at earthquakes. Nothing over a 6 magnitude. We're going to scroll up the list and try to keep this short, as I know people have stuff to do. There's Japan, showing a deep quake. It's a 151 kilometer depth quake at a 4.3 magnitude. Please bear with me one moment, folks. Just checking the chat. And let's get back to the map. There's that. And coming in just, let's see, about less than 2 hours later, a large quake strikes a 4.5 magnitude quake at extreme depth strikes Fiji. The depth is 567 kilometers on that. Small deep quake at Alaska. 4.8 magnitude quake at Indonesia. So we saw an event yesterday that looked like it could be foreshocks, but nothing bigger happening there. I think the largest of the past 24 may be this 5.4 at the mid-Indian Ridge. Not the most common place for earthquakes there. And just scrolling. We're going to talk about anything weird at very extreme low depths or deep depths, and that's about it. Let's look at volcanoes. Klyuchevskoy, having erupted into the stratosphere a couple of days ago, is now still erupting. Flight level 20,000 there, not stratospheric, but significant. Karimsky back on the list now, although volcanic ash not identifiable. Mount Aso, flight level 6,000 there. Tukono, flight level 7,000 there. Popocatépetl, flight level 20,000 there. And yes, I did go to the Ben Shapiro School of Explosive Speech. Although I'm not as explosive as Popocatépetl, Rincon de la Vieja in Costa Rica is back to erupting. Flight level 3,200 there. Phreatic explosions generated a gas steam plume. Sangay erupting, exploding, indeed. Flight level 19,000. Revenador exploding, flight level 16,000. And Sabancaya emitting steam, an indication that it could explode. Steam emissions are a sign of exploding things to come. Phreatic eruptions. Have you checked out our playlists on YouTube? If you haven't liked and subscribed, please do so. Check out our links up here. And also, check out the playlists. Now, you can't view my liked videos, but you can see the daily space weather. There's 303 videos in there already, and there are even more. We haven't even put them all in yet. As well as terms defined, the diamond anvil too hard to smash, aquarium videos for your lockdown play. Are you locked in a cave right now? Are you hanging out with Johnny Depp and trying to figure out if he's crazy or not? To reiterate, I don't think Johnny Depp is crazy. He seems well adjusted. All right. We're also on other social media like BitChute, Minds, where you will not get censored at all. And let's talk about Chinese virus that's made in China, and how you can just take your pen and just go out in the sunlight and be like, and just, it's like out of here. The mortality rate's going to be 0.05 to 0.09%, or maybe even less than that. Yes, 0.05 to 0.09% case death rate is, I believe, what I've been saying for, 6 weeks now? Please leave a comment if you remember how long I've been saying that for. And let's go on to talk about some concerns about Hong Kong. China's parliament approves a shocking bill allowing them to, I believe, do what all the protests were trying to prevent them from doing, which is take senators and ship them back to China for saying bad stuff about the Chinese Communist Party. Not a good sign for Hong Kong autonomy at all. Ask David Dubine, he'll agree. Next looking at the smAsho.com/forum. If you haven't been there yet, I just want to give you a small tour. smAsho.com/forum. Here's the nickel tour. One of the things we've got is a coronavirus section. So just come down to the free-for-all forum. By the way, the whole thing's free for all. It's a humanitarian effort to get people to understand some science. So we have it pinned on the free-for-all forum. And if you're wondering about timelines, ours started on January 23rd, was updated nearly every day, and is now over 30 pages in length. smAsho.com/forum. I've survived a global pandemic so far, and so have your ancestors. In fact, your distant ancestors survived things that were actually very, very deadly and frightening. We won't talk about it in this episode. Do you follow me on Instagram? You may see great posts like this one. Have you been to Pennsylvania lately? Well, come visit right after Tom Wolfe says you're allowed. Here's what I was looking at some point yesterday. In a classified location, I was tiptoeing through the non-tulips, and it was lovely. So get outside, folks. Get some sunlight. But before you do so, maybe read a article by Mitch Albom, one of these blue star nabs on Twitter. This guy is a museum-grade Covidiot. I'll tell you why in a minute. He's an editorial columnist at USA Today, apparently. So read today's sharticle. Thanks for leaving a comment, Oppenheimer Ranch Project. So thanks, Mitch. Perhaps follow Mitch on Twitter. He might put up more pathetic displays like that post. By the way, thanks to the FDA for removing labeling requirements requiring food companies to list the labels for the food. So brilliant. And another great tweet from Dan Crenshaw that I'd like to cite. Today, the House will be implementing proxy voting. Democrats don't believe they should have to lead from the front and show up to Washington to vote because they're scared and they want to telework. And they think you should be scared too, which is not leadership, it's cowardice. So the government, once again, the only non-essential personnel, unlike you, who are essential. No offense, Dan Crenshaw. Legislators like you are indeed essential. Let's read a little tidbit from this article by Mitch Albom. Check this out. But then, this war is not about sending our young men and women overseas. It's about shoppers and churchgoers and bar hoppers and partygoers and factory workers and hospital staff and police forces. It's a war of the everyman. We are all potential victims and all potential killers. We forget the latter faster than the former, but it's the truth. No matter how brightly the sun is shining, no matter how desperately we want to get to an open restaurant, we pass the disease to one another. No one dies if no one spreads. You can stay home and magically save people's lives, folks. Siren calls are luring us from our safe zones. Oh, do you hear the siren calls of going to a bicycle race? Oh, there's money to be made, work to be accomplished, and beaches to be visited, nails and hair and things to be cut and beautified at the expense of people's lives and perhaps their souls as they're cast into an ever-deepening and darkening abyss. Oh, I think I might have editorialized a little bit. Have you checked out our coronavirus section? Now, USA Today's offering a timeline. I'm sure it hasn't been edited at all. Ours hasn't been edited at all since January 23rd, when I started out things by putting a long Wikipedia article about what coronavirus are and the classifications and yada, yada, yada. smAsho.com/forum. Thanks everybody who's setting up logins over there and posting things. Sorry that I can't constantly be posting, but the forum is set up to run itself, so please ask for admin. We will give it to you if you are a solid user that we trust. And looking at the weather.gov map, seeing the flooding looks like it's subsiding a little bit here, although the hydrologic forecast in the Northern Rockies still looks bad as they got 2 standard deviations above normal snowfall probably this year, just like the entire northern hemisphere. I don't know if you're aware, but it's true, folks. It's true. Let's look at the snow depth, just because somebody's probably recently told you that OMG, OMG, Greenland is melting. Let's go check a real-time map about the current state of affairs at Greenland. Now that we're approaching summertime in the northern hemisphere, you may be horrified and shocked to see that, boy, that looks melted, huh? Let's check the depth near that webcam. Oh, more than 5 meters over there. Only 185.2 inches there. But here, there is only a dusting of snow, which means the northern hemisphere is melting and rising sea levels. Thank goodness for Chinese dams, or we will all die. Oh, no. Let's take some more depth measurements. How about up here in the sea ice? How much snow is there on the sea ice? Oh my gosh, it's only more than 5 meters there. How about out here? More than 5 meters, more than 5 meters, more than 5 meters. How about the southernmost tip? Oh, there's sea ice on the southernmost tip and 185 inches of snow, as well as 190 inches of snow there in Iceland. Oh no, the Arctic is melting, the Arctic is melting. Stop the presses, stop the presses. Allow governments to control every aspect of your lives today, because coronaviruses are very, very spooky, and the planet is so hot that it's extra cold. Next, back to the normal everyday pressure maps instead of ranting about how hot the planet is. Oh my gosh, it's so hot on Earth. Oh my gosh. Because you know extreme heat. We're advancing the pressure forecast here into tomorrow. You know that extreme heat has always caused excessive amounts of snow. And I don't know if you know about the mechanism by which planets glaciate. Let's talk about some dudes that aren't cold at all. Some of the nicest guys with the most tattoos and piercings you'll ever see in your life. Scum Incorporated. Clothing for low-life individuals. My first original bicycling team, where we all raced mountain bikes, and it got pretty serious pretty quick once I got on the scene, having gone pro in less than 3 years. So anyway, there is the windy.com map, and there's where we expect pressure cells to be at 12 noon tomorrow. Yes, it's a forecast, folks, the GFS one. Here's jet streams, and those jet streams are meridional, as they're flowing like this instead of like this. If you see a jet stream that's going east to west instead of west to east, that's not normal. Here's the Western world's jets. And there you see extremely bizarre weather phenomenon over the central U.S., the Mississippi Valley. And we won't worry about that and look at other images. Next, we'll look at water vapor maps for Europe and Africa. There are those. Here's me. Let me check the chat again, and we don't see any comments. Cheers, it's all good. Next, looking at the water vapor maps for Oceania and the Far East. Or you could say the Orient, but I wouldn't want to offend anybody by saying the Orient. Next, lightning maps. We saw some yesterday, and I think it was Mississippi. Today, Alabama's getting struck. Selma, there's thunder rolling in. Next time you hear some, lightningmaps.org, it's good times. Forecast thunder, freak out your friends. And here's what's going on in the U.S. Doppler. We've got storms that are moving the wrong way, which is no surprise, as we have basically a clockwise rotating low pressure system in there. And it's very strange. Look at this storm down here over Alabama that's causing that lightning. It is bizarre. Keep an eye on the weather, folks. You may see a storm come in from the complete wrong angle, and that's just the way it happens. Here's what's going on in the cloud layer. And you can see that. Oh, actually, that is counterclockwise rotating. My mistake. That's a counterclockwise rotating low pressure cell there. It's quite large. And it doesn't have a whole lot of dry air in it, it looks like. Let's take a closer look here by looking at water vapor. And there's what's going on in the water vapor mode. check out this moisture here. It's moving almost due north. We've got this dry air pushing north like this. And for you weather noobs out there, dry air is more massive than moist air. Let's take a look at this zone over Alabama. Shout out to Colin from, I believe, Montgomery, is it? Shout out to Colin if you watch the daily videos. Leave us a comment about bonds and intentionally initiated financial collapses and why the price of gold and silver were proportional to the downfall in the stock market at the beginning of the economic crisis. Anyway, we see a little wobble in the satellite there. That's the kind of thing the cosmic ray flux causes, by the way. A little bit of data distortion. Thanks to our patrons. Thanks for being the real source of funding for the content as YouTube strives to pay us nothing. So please consider becoming a Patreon or a subscribe star. We've got different tiers. Thanks for your continued support. Please tell your friends, tell your foes. We'll even be nice to those. Tell your science noobs and tell your science pros. Thanks to the Smash team for doing stuff like sharing the videos and commenting. And thanks for flying American Smashways. As I head back to the cockpit, please keep your head and arms inside the Smash plane at all times. We've got some more images of the local yellow dwarf. And there is the rising region, which is a cycle 25 plage. This is led by South Pole polarity, indicating it's the newer cycle, cycle 25. Doesn't appear to be a sunspot yet. Let's take a closer look. I don't see any umbre, but it's not fully risen yet, and it's tough to see in a very, very thick tube of plasma. So, and let's look at the 94 angstroms view, which should probably tell us something about where that X-ray flare came from. Again, my best guess is that it's from this active plage here. Let's see what happens. And let's let that load here. Again, this is a 48-hour view from the SDO satellite, the Solar Dynamics Observatory. And you know, that flare might have come out of one of those active regions that's rising in the east. Let's let this play through. Okay, I think I saw the flare come out of this plage. I think it occurs up here on the top part of this plage. Right about, I think that was the solar flare right there. And it was coinciding with a little wobble on the apparent image on the camera. So that could be a coincidence. Probably not, though. So anyway, we see these two active regions rising. Thanks for attempting to understand the physics. Thanks for becoming a sun groupie. Again, please share the content on your social media and help our channel to grow. We've got a lot of things to do in 2020, and we aren't even halfway through them yet. The shirts are coming, folks. The shirts with massive radio galaxy Cygnus A, otherwise known as 3C405. They're coming. And it's going to be soon. So look for those. Again, thanks for tuning in. Remember, stare at the sun, don't drink, and if you do, don't drive. Seriously, don't drive. Get outside. Get some sun. Get some vitamin D. If you're locked in a cave, supplement vitamin D. For goodness sakes, get your vitamin C. Have a brain. Don't be a Covidiot. Have a delightful day. And may the atherosclerosis be absent from your arteries. And may the Covidiots be absent from wherever you are.